For thousands of years, humanity believed the moon was simple. It rose in the night sky, changed its shape slowly from crescent to full, and quietly guided calendars, myths, and navigation across civilizations. Ancient cultures gave it names, gods, and stories, but one idea remained unchanged. The moon always showed the same face. And that created one of the most persistent misunderstandings in human history, the idea of a dark side of the moon. The phrase itself sounds mysterious, almost forbidden. A hidden hemisphere that never sees sunlight. A permanent shadow zone where the sun never rises. But modern science has revealed something far more precise and far more interesting. There is no permanent dark side of the moon. Every part of the moon receives sunlight during its lunar day, which lasts about 2 Earth weeks. The real difference is not light or darkness, it is visibility from Earth. For all of human history, one half of the moon remained unseen not because it was dark, but because it always faced away from us. That hidden region is called the far side of the moon, and uncovering it became one of the most important milestones in space exploration. Why we only see one side of the moon? The reason we always see the same lunar face is due to a process called tidal locking. The moon is about 4.5 billion years old, and in its early history it rotated more freely. Over millions of years, Earth's gravitational pull created friction within the moon, slowly reducing its rotational speed. Eventually, a stable balance formed. Today, the moon completes one rotation on its axis in exactly the same time it takes to orbit Earth, approximately 27.3 days. This perfect synchronization means one hemisphere always faces Earth, while the other always faces away. However, the moon does not remain completely rigid in its motion, because its orbit is slightly elliptical and tilted. This motion, known as libration, allows observers on Earth to see slightly around the edges of the moon. As a result, humanity can observe about 59% of the lunar surface over time. The near side experienced more volcanic activity, while the far side remained geologically more ancient and preserved. This asymmetry became one of the key scientific puzzles of lunar research. Why the two sides are so different? The differences between the two sides of the moon are not random. The near side contains large, dark regions known as maria. Ancient lava plains formed billions of years ago when molten rock flowed across the surface. The far side, however, has a much thicker crust. This made it harder for magma to break through the surface. As a result, it remained heavily cratered and geologically inactive compared to the near side. This difference likely formed early in the moon's history, possibly influenced by gravitational interactions with Earth and internal heat distribution. The result is a natural split between two lunar worlds, one resurfaced by ancient volcanic activity, and one preserved in near-original condition. To understand the moon's surface, we must look back over 4 billion years to a time known as the Late Heavy Bombardment. During this period, the inner solar system was filled with debris, asteroids, comets, and planetary fragments constantly colliding with planets and moons. The moon, lacking an atmosphere or geological recycling, became a permanent record of these impacts. Every crater on its surface is a frozen moment in time. The far side, with its dense crater fields, preserves this ancient history more clearly than almost any other object near Earth. After decades of robotic exploration, a new era began in 2019. A mission successfully achieved the first soft landing on the far side of the moon. Because direct communication with Earth is impossible from that region, a relay satellite positioned beyond the moon was used to transmit data. The lander touched down inside the Von Karman crater, within the South Pole Aitken Basin. A small rover named U-22 began exploring the surface, analyzing soil and studying the geology of a region never previously visited. In 2024, another mission achieved a historic breakthrough by returning samples from the far side to Earth. These samples provided direct evidence that the far side's interior composition differs from the near side, confirming long-standing scientific theories. At the same time, another mission successfully landed near the moon's south pole, collecting data on temperature variations and surface conditions, essential knowledge for future human exploration. For the first time, the far side of the moon was not just seen, it was physically touched and studied. In 2026, humanity returned to deep space in a historic crewed mission around the moon. Four astronauts launched aboard a next-generation spacecraft and traveled farther from Earth than any humans had gone in over half a century. Their trajectory took them around the moon, including a passage behind its far side. During this phase, communication with Earth was temporarily lost due to the moon physically blocking radio signals. For a brief time, the crew experienced complete isolation in deep space. Outside their windows, they witnessed the far side directly. A silent, cratered landscape illuminated by sunlight, completely untouched and unchanged for billions of years. Then, as they emerged from lunar shadow, Earth appeared again, a blue sphere rising above the horizon. It was a reminder of how small, fragile, and connected everything truly is. Why the far side matters for the future. The far side of the moon is one of the most scientifically valuable locations near Earth. Because it is permanently shielded from Earth's radio signals, it offers an ideal environment for radio astronomy. Scientists believe future telescopes placed there could detect signals from the earliest stages of the universe, long before stars and galaxies formed. It may also serve as a base for long-term human presence, scientific research, and deep space exploration. Plans for future exploration include orbiting stations, surface bases, and long-term lunar habitats. These systems will support missions across both the near and far sides of the moon, turning it into a stepping stone for deeper space exploration. Water ice deposits near the lunar poles may provide fuel, oxygen, and drinking water, making sustained presence possible. What was once unreachable is becoming a place of human expansion. After centuries of mystery and decades of exploration, one fact remains clear. There is no dark side of the moon. Only a far side, once hidden, now revealed. The moon is no longer a distant mystery. It is a world we have mapped, touched, and begun to understand. And yet, even as we uncover its secrets, it continues to remind us of something deeper. The universe is vast, and we have only just begun to explore it.